explosion. Okay, today's lesson is very similar to the one we just did. If I was in a normal block class, I'd do them both in the same day. But since we don't have that, we split it into 2 days. So last class we turned words into expressions. This class we turned words into equations and inequalities. Right? What is it that you look for that tells you that what you're dealing with is an equation? There's an equal sign, right? So, and if it's an inequality, what are you looking for, Adam? No, Lily. No. Well, let's just say here, for an equation we look for equal sign, right? Equals. For inequality, we look for one of those 4 symbols. Right? You have to know these 4 symbols, right? Instantly, what they mean, and not have any confusion about what is a greater than and what is a less than. I find sometimes at this level, we don't, but you're going to have to get used to that. So what does the bar underneath the symbols mean? It says or equal to. So there's 2 of them that have or equal tos and 2 of them that don't. Right? The thing to keep in mind is when you're writing using an inequality symbol, the lesser number is always on the pointy side. Right? It's always opening up to the bigger number. And you're always kind of describing the relationship of what's on the left to what's on the right. If I write 2 is less than 3, right? 3 is less than or equal to 3, right? It's not less than, but it is equal to. That's okay. So just keep in mind, the smaller number is going to go on the pointy side. Do you have any other way to remember those? Anybody? Kaylin? Okay. I was going to say, I've heard some kind of crocodile reference before when it comes to those things. Okay. So Felicity's saying, if you look at this symbol here, just try to use your imagination. It's kind of like an L. Yeah. And then if that's the less than, then that's the greater than. Remember, there's only 2 possibilities here. And then just understand what the or equal to means. Okay. So we're not solving these things. We'll get into that more of that later. We're just trying to turn words into math expressions, or this time equations and inequalities. So write the equation or inequality. The difference of a number and k and 8 is 12. What does the difference mean? Yeah, subtraction. So it's a difference. Overall, it's a difference. But they're saying it's a difference of, right? What's going to go in front of that subtraction? Twice a number k. How do I write that? 2k and 8. So it's the difference of 2k and 8. 2k minus 8. How about the product of 6 and a number n? Oh, sorry, I didn't finish that first one. The difference of twice the number k and 8 is 12. What is that is telling you? That's equals, right? That's equals. Like that. Okay, now try the next one. The product of 6 and a number n is at least 24. How do I write the product of 6 and a number n? 6n. Okay, is this going to be an equation? No, it's going to be an inequality. Okay, so which is the inequality that would describe at least 24? What does that make the possible numbers? 24, is 24 at least 24? Is 25 at least 24? 26, 27. So it starts at 24 and goes up. Which inequality symbol should we use? Is it greater than or equal to? And a number y is no less than 5 and no more than 13. This is one you probably haven't seen before. Oops. Get this over here. So this is something you think the others you probably kind of sort of knew what you're doing. This one is new for you. So you're going to have to like wrap your brain around this. The number y is no less than 5. So does that mean it's greater than 5 or less than 5? Yeah, so we write this like this. 5 is less than or equal to y, and it's no more than 13, so it's less than or equal to 13. Right? What they're telling you is that the value of y is somewhere between 5 and 13. And the way we write that is with what you call a three-part inequality. So you show the y in the middle of 5 and 13 and have two inequality symbols. Right? And they got to be pointing in the same direction, right? It's got to be like less than, less than. I mean, if it's a greater than, then it's got to be a greater than. But they got to match. And the one thing that's true that you should keep in mind if you write a thing like this, it should be that this number has to be less than that number, right? If 5 is less than or equal to some number y, and that number y is less than or equal to 13, that's actually a property that we learn that tells us, well, that means that 5 must be less than 13. So if you set it up in a way, maybe you had the 13 over here and the 5 over there, and it didn't pass that test, then you're going to have to say, well, I think I did something wrong. Okay, so this is called a three-part inequality. Okay. Okay, you try. Try to write this down. The quotient of a number p and 12 is at least 30. See if you could turn that into the equation or inequality that it is. You write the quotient of a number p and 12. Ty? The quotient of a number p and 12. Okay, so that's that part. Okay, now is at least 30. Which symbol are you going to use? What are the values then? Could it be 30? Could it be 30? Could it be 29? Could it be 31? Actually, it could be like 30, 31, 32. Okay, which symbol are you going to use to say that? Greater than or equal to 30. Okay, so when you substitute a number for the variable, that means that there is no more variable. So you can actually calculate what is the value. You're evaluating at that point. And what you have in front of you, since it's an equation or an inequality, either it's going to be true or false. If it's true, that means you just plugged in a solution. If it's false, that means that's not a solution. And when we learn about solving equations, we always check our answers, and that's what we're checking. You know, if we plug it in and it leads to a true statement, we said, I got the right answer. If we plug it in and it doesn't lead to a true statement, then it's not a solution. So let's look at that. Check whether 3 is a solution to these equations and inequalities. Again, how am I going to check to see whether 3 is a solution, Hunter? substitute x equals 3. I mean, it's really, we're evaluating the expression on the left for x equals 3. So let's write this out. 8 minus 2 times 3 equals 2. 8 minus 6 equals 2. That means 2 equals 2. Is that true? So you say yes, that's a solution. Solution. Okay, how about the next one? 4 times 3 minus 5 equals 6. Simplify. Order of operations. What do I do? Which calculation am I going to do first? 4 times 3. 12 minus 5 equals 6. What is 12 minus 5? 7. 7 equals 6. So that was not a solution. So we have to say no, not a solution. Okay, how about the next one? 2 times 3 plus 5 is greater than 12. 6 plus 5 is greater than 12. That tells you that 11 is greater than 12. What does that tell you? It's not a solution. 11 is not greater than 12. And the last one, 5 plus 3 times 3 is less than or equal to 20. What is 3 times 3? 9. Less than or equal to 20. So 5 plus 9 is 14. Is 14 less than or equal to 20? Yes. So that's a solution. I mean, the truth is when you take multiple choice SOL kind of test, you know, it says solve the equation, they give you 4 possible answers. A lot of you are going to just start substituting the answers until you find the one that works, right? You're going to do this exact process. Not that I'm recommending that, but I know that that's what happens. Okay. So you try these 3. And now the way these are written, I'm sure the homework is written the same way. So there's the equation, 9 minus x, right? That's the number you're substituting. So after the colon, that's the number to substitute. So for each one of these, substitute that number and tell me if it's a solution or not. For the first one. Connor. 9. Yeah, you should have written 9 minus 5 equals 4, 4 equals 4. So that is solution. Okay, who's got the second one? Go ahead, Evan. Yes? Okay. So you substituted 7 plus 5 less than 15. 12 is less than 15. That's a solution. Usually I abbreviate solution, SOLN. Okay, who's got the third one? Somebody else. Ava? You did the third one? Ava. What did you say on the third one? Solution. What did it equal? When you substituted in the 9, what did you get? It ended up saying that 21 is greater than or equal to 21. Is that a true statement? That is a true statement. The or equal to part picks it up, right? What if you forgot the or equal to part? Then you got the wrong answer. Attention to detail. Okay, mental math. I'm just kind of covering these things because they're in the section, and I don't think you're going to find them too challenging. We didn't get to the point where we're solving equations yet, but these are the kind of things that in your mind you can probably solve without actually following steps. You know, the way I like to look at it is a one-step simple math thing like this, when we get to solving equations, is the kind of thing, it's okay to just say, I got that one. More than that, you've got to show every step. All we're really doing here is saying, what do you think I would plug into X so that this was a true statement? 6. Okay, what do you think I would plug in for n so that this is a true statement? 6 times 7 is 42. Okay, what would I plug in for y so that this is a true statement? 12. Can you see that? Right, Christine, you get that? How about, what is it that divided by 5 equals 9? 45. That's what they're calling mental math. What's that? Just try to imagine what number you would put in the position of x so that that number plus 4 equals 10. Right? Just because we haven't gotten to solving equations yet, so this is mental math only. So that was a 6, that was a 7, that was a 12, and that was a, did we say that one? 45. Good. So do those 3 for your U-try. Say in the first one. What number plus 6 equals 11? 5. What number times 5 equals 40? What number divided by 4 equals 10? 40. So mental math is easy. Okay, last slide, I think. The last time you and your friend and 3 friends went to a mountain bike park, you had a coupon for $10 off and paid $17 for 4 tickets. What must have been the regular price for the 4 tickets? Okay, so what was the total price? I mean, if it was discounted 10, well, whatever that price is was discounted 10 and equaled 17. So what does that make the value of P? You already said it, 27. I mean, that's a word problem, but it's kind of getting at the mental math. You could set up a little equation, use mental math to solve. Yes? Yes. It was just asking for the total price, right? Because it cost 17 for 4 tickets, and then there was a $10 discount. How would you find the price for just 1 ticket? The regular price for just 1 ticket. You would have divided that one by 4. You would have found the total, divide by 4. That was actually a second part of the problem that I cut off. And this is the last player. A basketball player scored 351 points last year. If the player plays 18 games this year, will an average of 20 points per game be enough to beat last year's total? So what are they? How could we set this up as an inequality? How many points did he score last year? And then this year, they didn't tell us exactly, but if he plays 18 games and averages 20 points per game, how are you going to calculate the total points? 18 times 20. And because they ask whether he's going to get more points, what's the inequality we're checking to see? Yeah, that's the question. Is 18 times 20 greater than 351? If you're not sure, put it in the calculator. What is 18 times 20? 360. Well, he said to beat last year's total. They didn't say to equal it or better. So I'm going to guess they meant greater than. So this is yes. Okay. So write down the homework right there. Write it down. It'll be as easy as that lesson just was, right? And then take out a piece of paper, put everything else down. We're taking a quiz. It can be pen or pencil, I don't care.